Good morning, good afternoon, everybody. Welcome to today's installment of the TIBCO Analytics Meetup. The usual confidentiality and disclaimer notice. And advertisement here for the TIBCO Spotfire online user group. Got about 800 folks in this group at the moment. If you sign up for this, you'll automatically get email with the slides and links to the recording of the session and access to the site where we archive those. Today, I'm going to give a quick update on the Connected Intelligence portfolio. We've got two fantastic demos. One that was rapidly put together by a global team around life expectancy analysis, and then a demo on our Formula One work, including applying predictions in real time for understanding lap time, probability of crashes, things like that. And then you'll get an update at the end on the community outreach program. So let me jump in and give a quick update on the portfolio. Three pillars: interconnect everything with API-led microservices, hybrid integration, and then the other two pillars that will be represented today: the predict pillar, including visual analytics with Spotfire, TIBCO data science, and operations analytics with real-time data feeds, and then unifying data underneath that with our TIBCO data virtualization and master data management products. And we tie these together by turning data into insights, into actions, into learning, and closing that loop around applications like you're going to see today, including healthcare IoT type applications. You'll see our data science product for accessing and preparing data, building out models in both point and click and Python notebooks, deploying those models for batch and invocation on real-time event streams, and then feeding into business applications. You'll see today an IoT application as well as a healthcare application. There's a number of Spotfire applications on our demo gallery. You see the link to that at the top of the page here. One of those includes the IoT F1 demo, parts of what you'll see today, a variety of other applications from different verticals that include data wrangling, data science, Geo-Analytics, and streaming across those functional areas. You'll see today examples of three different personas. You'll see a persona of someone who creates modifications, the developer on the software, including custom operators. That developer persona builds things in the surround of the products to make it easy to deploy for others to use. The data scientist persona in the middle here, someone who's developing and analyzing data in our data science Team Studio product, as well as in Spotfire, and configuring the downstream business analysis experience, making sure these jobs run at scale, and developing various scripts, Python, R, and so on to make that happen. And then finally, the business analyst who stays in Spotfire, enters a few parameters and gets the benefit of the work of the other personas in scalable jobs that feed their Spotfire interactive experience. And you'll see these personas illustrated with the two examples today on healthcare outcomes modeling and the IoT F1 example. So this is enabled with this Spotfire data function concept where you get full R and Python capabilities inside of Spotfire to call out to functions that run in Data Science Team Studio, for example, mapping the Spotfire data tables to data frames in R or Python pandas tables, and bringing to bear the power of Spotfire's Geo-Analytics and real-time analytics on top of that. So you'll see the diagram at the right here, being able to circle from Spotfire into those different environments, including our own data science product, as well as R and Python to inform the visual analysis. You'll see extensive use of our Geo-Analytics capability in Spotfire with inbuilt WMS, TMS services, shapefiles, Esri services, multiple coordinate systems, and ability to configure data functions to run on highlights and markings and so on from the Geo-Analytics interface. You'll see a little bit of our real-time data streams inside of Spotfire, where live updates on some visuals can be pushed. Same experience you have of interacting and brush linking those to static data sources just works like the rest of Spotfire, except you now have the ability to update and do real-time data streams inside of that visual experience. And then enabling all of that, the data wrangling capability in Spotfire and also in Team Studio for preparing data, cleaning it, creating features, and pushing data frames, into both a Spotfire visual as well as a downstream machine learning workflow. So those are some of the technologies you'll see highlighted from the stack today. And without any further ado, I'm going to hand off to Stephen to take us through the health outcomes life expectancy demonstration.
Great. Thank you very much, Michael. So yes, I'm going to show you a demonstration that illustrates precisely those points that Michael just made, the different stacks, layers of the TIBCO analytics platform and the personas that interact with those. And the context here is a challenge that was issued to us recently for a conference in Sydney, actually a global conference. We still yet to deliver it in the US and in Europe. The focus you'll see today is more around APAC and Australia and New Zealand. But we were challenged to look at health outcomes as expressed in life expectancy around the globe based on inputs that are largely sort of socio-economic in nature. And if you want to read the full details of how we did this, including the technology and the statistics and so on, you can take a look at our TIBCO community blog. There actually you'll also find a more current blog that Michael has been leading with the data science team at TIBCO on the current outbreak. This is less focused on the specifics of any particular health crisis and more just on general health outcomes. But I think it'll amply demonstrate the sort of personas that Michael was just talking about. So let me switch to the live demo. Here you see I'm logged in as myself, in fact, to our TIBCO data science platform. And this is not a fake system. This is actually where we run most of our analytics projects, including the one that I was just talking about. And you can see just a few weeks ago, there was a little spike of a few days where part of my team was focused on modeling life expectancy for countries around the world. And so you can see the spike of activity really over the course of 3 or 4 days. The team came together because we sort of learned about the challenge a little bit later. We didn't have much time to work on it. And actually we sort of turned that to our advantage. How can we rapidly bring a team together to produce some meaningful analytics as quickly as possible? So here in this workspace, everything in the TIBCO data science world is divided into project workspaces. And you can see the recent activity here, including that blog that I was just mentioning on the current outbreak, which I added to this workspace. But again, getting back to this particular analysis, this was the team that was working on it. If I look at the team in general, you'll see we've got here a data engineer, business analyst, data scientist, myself as the owner of the project, listed out, as well as some other people who are just sort of auditing. And that's really what I want to call out as I go through the demo, is how these different personas interacted with each other. We even actually changed our names just to call out the roles that we were playing. So you'll see I start out in the persona of Neil, who is our business analyst, who is working with Spotfire to do some initial data wrangling, get the data prepped and come up with some initial insights before he then passed off to me to sort of set up the data science side of the project and do some very basic analysis as sort of a business owner. And then I handed off to Prem, who is our data scientist, perhaps what one might arguably call a citizen data scientist or a data analyst, who then did some preliminary modeling with some assistance from Emily, a machine learning engineer or data engineer who was doing some work in Python, before we then yielded the results back to Neil for review in Spotfire. So this was the little team that was working together. And as I say, just in a few days, we produced something that you're now about to see. All of our work is collected here together in the work files area. So you see here visual workflows, Python, and SQL, notebooks, predictive models that we've exported, links to Google Sheets and so on. Pretty much everything is collected here and then sort of audited over time through this sort of interactive activity stream. Let me focus to start with on the dashboard that Neil created as the business analyst. This is in Spotfire, running on the web. In fact, everything you're seeing here is running in cloud. It can also run on premise, of course, but here we're running everything on Amazon and using Amazon data sources. And so here's what Neil started with. He did some basic pivoting and unioning of data sets to get a comprehensive data set. We decided, because the data set was relatively small, we wanted to bring in data from really around the globe and not just focus on the initial area, which was Australia and New Zealand. And so we'd have just more data points. So there's the data. We found that there were a lot of missing values. Spotfire automatically actually pointed that out to us, made some suggestions about charts that we could look at in order to dig further. If you see here, for example, there's a nice little chart showing these missing values that Neil endeavored to fill in. You'll see, for example, there's a potentially quite useful variable here about population living in urban areas, but really very little data across the different countries and across the years. It went from 2016, contraceptive usage, economic factors, trading factors, and so on, as well as the actual variable that we're interested in, life expectancy at birth. And fortunately, there you can see there are no missing values. We looked at a variety of different methods of filling in those values here in Spotfire. We can actually use some R code embedded within our dashboards to fill in missing values using basic sort of interpretation, like linear interpretation, more advanced methods using sort of piecewise, using splines. We decided to stick with linear. It actually seemed to give pretty good results. It was quite simple. And so having done that, Neil was then able to fill in the missing values. Here you see the results after. There's still some way you just don't even have enough data to interpolate, but it's much more comprehensive and rich data set now. Neil then sort of started playing around with this. He looked at perhaps some initial measures of variable importance using a basic regression that's built into the data relationships tab within Spotfire. He also built a basic dashboard here, just looking at different countries and looking at values of life expectancy, just to get a broad sense of what was happening from country to country. Again, focusing here on Australia and New Zealand, so I can sort of isolate that in the map here just to call that out. I can look across different countries, see here the Nordic countries, perhaps not surprisingly, having particularly high percentiles in terms of longevity, significant improvement over the 16 years, 17 years for Ireland. But at this point, Neil decides to hand over to the data science team to do a more advanced analysis. So that's where I come in to sort of set up this project. I create this workspace, link back to the Spotfire dashboard from within here. And I actually created a very simple, so think of me as sort of, the idiot manager, doesn't know what he's doing, but can do some basic stuff here using this visual workflow. So I'll open this up. And what I did is I did a very simple classification. We just said, let's look at a histogram of life expectancy and see if there's sort of a cutoff point for countries that are doing well and not so well. And we'll just do a binary classification. So that's what we do in some of these simple steps here. And I was able to do this, no coding required here. So for example, if I want to fill in some additional missing values, I can just check those here and pick whether to use a fixed value or an aggregate or a median, for example. Very easy for me to do that, create a binary outcome variable, and then do some basic modeling. For example, here I built a simple decision tree to look at sort of what variables might be interesting for this particular analysis. Also, I used our AutoML orchestrator. This is a really great feature that allows me to take something like a binary variable and build an automatic model, build a set of classification models automatically and get a leaderboard out the other end that just shows me now which are the best models. Here it's actually recommending a logistic regression, and it'll actually produce for me a comprehensive set of explicit workflows so that it doesn't just give me a model and a recommendation and a set of statistics. It actually constructs the entire workflow from data access to data prep to features, feature selection, modeling, even out to explainability. We even have an entire workflow built out that not only strings together all of the best transformations and models that the AutoML finds, but then actually builds some explainability and pushes that back to Spotfire so you can get a sense of not just which models are best, but also why they're best. That's the AutoML. Again, very easy for me to do that as sort of the business lead here. I can also build, without any coding, just some basic classification models here, use standard techniques like ROC curves and confusion matrices to figure out which ones are doing well. But sort of reached the limit of my expertise here, so I'm going to hand off to a real data scientist, Prem, and this is the workflow that Prem created. This is a full modeling workflow. We're actually going to predict life expectancy here, so numerical regressions. He got some help here from the rest of the team. As I mentioned, Emily created some Python notebooks, and I sort of contributed some ideas as well as Neil, some findings from his dashboard. Let me open up and just sort of show you briefly what Prem did in his workflow. You see there are some other workers using this right now. So we did similar process of data munging up at the beginning of the workflow. We use a method called correlation filter, which we really like to use, which basically says, look, there are actually, I think, hundreds of socioeconomic factors that were in this data set. So we need to trim those down a little bit. And we used various techniques for doing that. One of them is just simply to look at any variables that are strongly correlated with each other. Some of these employment variables, for example, sometimes have actual perfect correlations. So we just throw those out of the data set and pass that on to the rest of the workflow to simplify things and to make things easier, ultimately, for the business analyst to review which things were most important. Then we do standard things like normalization, split into a training and testing set based on time variable. And here we're not building classification models, but actual regression models. So you can see here the linear regression with its residual and QQ plots, and gradient boosting, some ensemble methods here, random forest as well, yielding variable importance. We build that model, run some predictions, build a regression evaluator to analyze some statistics about which model is best. We also look at predicted versus actual charts. I think we found in this particular case, this is analyzing all data from all countries. The linear regression seems to do pretty well. But in any case, we can export some of these models out now for both real-time and batch scoring. And what we also did, and you'll see this come into play in a couple of minutes when I go back to the dashboard, we actually filtered down to one country. The filter here is actually parameterized. So we say the country should equal a passed-in parameter, which is the name of the country, which is going to be, say, Australia or the UK or Ireland, whatever. And then we just build an individual regression there in order to determine what the measures of variable importance are for that specific country. And we're going to publish these results back to Spotfire so that we can yield the outcome of this complex workflow, this modeling workflow, back to the simplicity of the dashboard, as you'll see in a second. There are many ways of doing that, by the way. First of all, you can actually take the output of any one of these operators and surface that directly in the Spotfire dashboard using the data function Michael mentioned. You can also emit a data file that is going to be ready for reading by Spotfire in the Spotfire format, or you can just write it out to a database and Spotfire can access it through its database interactivity. So I'll get back to that in a second. There are other methods of deploying models that I just want to mention that we could have used. As I said, we're focused really just on deploying back to Spotfire. But here's one method. For example, we can export those models, as you saw me do with that linear regression. We can load that up and use it for batch scoring. So here's a very simple way of doing batch scoring. You can load a model that was developed on Hadoop and deploy it to Oracle, for example. Very easy sort of cross-platform model deployment here for batch scoring. I can then schedule that workflow. Here we have a workflow that runs every day. It runs 2 workflows, some custom modeling in Python, and then the workflow that I just showed you. And that can be scheduled. We can also run for real-time scoring. Here is an engine that I have ready. And this is simply taking an export of one of those models that I built. And at literally the click of a button, I can deploy that engine as a REST service. And now it's available here. I think I've copy-pasted some data here. So this is just passing in data for a particular country. And you run it, and it gives you a prediction of about 83 years old for this particular country, which I think is Australia. So very easy to deploy for both real-time and batch scoring. Before I head back to the dashboard and show you how we interact from that, I just want to mention one other thing. I mentioned that Emily was building these Python notebooks. And you'll see, in fact, although I use mostly these out-of-the-box modeling operators for building the regressions, that's what Prem did, he also asked for an AdaBoost model. And Emily had a particular version of that she had in scikit-learn. And so she coded that up in this Python notebook. This is a Python execute model. It's actually run using, what it does, it runs this Python notebook. Here it is, that Emily developed here, that builds the AdaBoost model and ships the results back. She's writing this just as she would any other Python notebook, but because this is operating within TIBCO Data Science, we're able to analyze that code and make it available as a node for Prem to execute within his visual workflow. So a really nice integration there, notebooks being callable from visual workflows, and as it happens, vice versa. Anyway, the point was we developed these measures of variable importance in this workflow, and it was then very easy for us to ship those back to Spotfire via the data function that Michael mentioned. So let me open up this dashboard once more. And here's the result. And this is what Neil did. Neil actually managed to build a simple interface here into the TIBCO Data Science platform using our big data data function, as we like to call it. And that executes the visual workflow on the back end in TIBCO Data Science, and then produces the results, yields the results back to this dashboard. So it's very easy then for the data scientist to work within the visual workflows and Python notebooks, but then to make those results available back to the business analyst, Neil in this case, for viewing within the dashboard, oblivious essentially for a casual viewer of this dashboard that what it's actually doing is running these complex workflows in the background. So here you see, for example, the results of the modeling. Might not typically have this in the dashboard, but you can see here the results of the predicted versus actuals that we were building in that workflow. Here, the measures of variable importance for a particular country, in this case, Australia versus worldwide. And here's another way of viewing that. On the left, the measures of variable importance for the worldwide models versus the country-specific model. So you can see, for example, this variable, which is female underemployment, is much less significant for Australia than it is worldwide. Whereas on the other hand, if you look at these two variables here, so that's the percentage of the female population with no education, as well as the consumer price index, are particularly important for Australia and perhaps less important in general for other countries. So very easy for me to use the power of Spotfire here to explore my data, both on the front end to get used to it, to figure out what questions I want to ask, to then pass that on to the data science team for producing more sophisticated analyses, and then back to the dashboard to yield the results of those analyses for the business analyst. So I hope that makes it at least a little bit clear how those different personas can interact with each other through TIBCO Data Science and Spotfire, and to build an integrated analytics pipeline from data prep all the way through to predictive models that can be deployed in batch or real time, and then ultimately out to visual applications. So I think I'll stop there and hand over to Colin, who will show another application of the TIBCO analytics stack. So Colin, over to you.
Yeah, great, thank you. So I'm going to show an example around Formula 1 simulation, and what I'll do is I'll just share my screen so you can all see this.
Looks good.
Thank you, excellent. So as you may well know, TIBCO has been in a partnership with the Mercedes Formula 1 team. I think we're just entering our fourth year together. And we've done a lot of work, and there's a lot of data science and data involved, obviously, in Formula 1. You know, they do masses of simulations, you know, something we often call digital twins, where you try and replicate a real life scenario or situation or process and convert that to a digital process where you can emulate it and start testing and predicting or analyzing how to improve that sort of process and thing that you're working on. So while a lot of Formula 1 information and data is obviously heavily guarded secrets and how they make the car go so fast and the drivers do so well, one thing that TIBCO has done is we've built our own Formula 1 simulator. So this is an example of the simulator that we've run. We ran this at Big Data London last year. And here you can see we've got this Mercedes car and the game here. And let me just show you this running and give you an impression of what we actually do with this. So here we go. So here you can see the guy racing. This guy was very, very fast. And then, as we've been talking about, this is streaming the data live into a Spotfire dashboard. And if I just pause that, you can see it's got various stats coming out the games, which is the speed you're going at, where you are on your track, and all sorts of attributes, even implicated G-force that the driver's experiencing. So as people drive, it's instantly in real time displayed in our dashboards. But what we wanted to do was bring in data science. What can we predict? And here you can see in the very top here, a little bit blurry in the video, but a predicted time. So we want to try and learn how we could optimize a driver's lap time, and then learn about what makes somebody fast versus maybe a slower driver. So I want to just summarize some of the technology involved, because obviously when you go into data science, and certainly with something like Formula One, you combine a lot of technologies. So what we're actually doing in our simulator is using this, the Formula One official game. That's the same game that's used in official esports championships, and all the F1 teams enter that with their esports drivers, so it's become big business. And it streams the data live out, and we pick it up using a Flogo, which is an open source edge technology. And the real backbone of it is TIBCO streaming, or Streambase, where it gathers all this data. It can do all sorts of things like running models in real time. So when Michael mentioned at the start, what we can do is have models that are predicting as data flows straight out into here. So every time we get information from the game, we can run a prediction. So we stream that all back into Spotfire, like you saw in that dashboard video. But what we're also doing is we're dumping all the data to Postgres, and that means we can use that data for historical analysis, for more in-depth modeling. And here, again, much like Stephen's demo of life expectancy, we've got the TIBCO data science part, building models, and what it's doing is it posts it out to our model repository, which then can update into our streaming application. And what's quite cool is when we did, so this is a real situation that we did run at Big Data London last year. We actually had models relearning and rebuilding as people raced, deploying in real time, and then going into the stream. So halfway through someone's lap, we flipped what model we were using to predict their lap time, and we could see in real time that that model had changed and better predictions happened as it learned. So just to summarize what I'm going to go into the details of the actual data science and the analytics we did, we set ourselves two challenges: predicting final lap time. So from the moment they're racing, can we predict? And that's quite hard early on in the lap. You don't know a lot about the driver yet. But also, as we learned from watching people race our simulator, there's a lot of erratic driving, shall we say. So we thought it'd be quite interesting to see, could we predict the likelihood of someone having an accident where they damage their car? So before we start actually going into detail, I'll give you an impression of the data involved and just get an idea of how much data these games and esports games stream out. So we get all sorts of different information covering track and tires and heat and speed and things the driver's doing, how much they're braking. And actually just one lap of the Brazil circuit, which is what we're going to use in this demo, generates nearly 105,000 data points. So that's just one lap. And imagine you get a few hundred people trying the simulator for multiple laps. So it outputs 10 rows of data per second of 130 columns. So it builds up very fast. So let me jump out into the actual demo. So again, much like the previous example, we're going to use Team Studio, our data science tool here, as the backbone where we collaborate. Here we can store things like PowerPoint, workbooks like we've seen before, Python notebooks, and also the Spotfire tools. So before we do the data science, what we wanted to do was learn how much can we learn from this data that we've got coming out of this game? How useful is it? So we built a Spotfire dashboard to do that. And this is what we've got. So I want to take you through examples here. So this is just one way we represented the data. So here you see the Brazil lap that we ran the simulator on at that event in London. And what we're seeing here is every single dot in this map, hopefully you can see it, is one data point that came out the game that was streamed out live. So the idea here is we want to analyze and learn from this. Could we learn to drive actually just from analytics without being in the car? So what we've done is we've colored the lap. So every point is colored. So I'll use this throughout this demonstration, but where you see pink or purple, that means they've gone very fast or it's the highest value. So in Formula One, when you say someone's going purple, it means they're doing the fastest time that anyone's done. So immediately we can learn by looking at the purple line how to drive this corner. You know, you can see that the people who go very fast go this route, whereas the green and the blue are slow, and it's not such an optimal route. So you can learn about the best place to be in the track. So I want to expand on that example a little bit, because what we can do is highlight parts of the track and actually learn about very specific detail about what makes someone fast. So in this example, what we're going to look at is a corner, the approach into this corner. So Formula One tracks are split up into 3 sectors. The third sector, you know, is the last phase before you finish your lap. And what we're seeing here is we're going to look at the approach into this corner and then how people come out. This is really crucial to getting a good fast lap time at the Brazil circuit for Formula One drivers. So what we've done is we've highlighted the straight before the corner, and here we've got some statistics. The numbers here on the left are the lap times. So these are very fast drivers, that's 70-second lap time, 75 seconds. And on the right are slower drivers with 100 to 110 seconds. And we've got their speed and the percentage braking, you know, how much acceleration or throttle, how steep they're steering in, so what angle is they're steering at. And what we can see is we can learn from this very quickly. Even though we're on the straight, the people who finish up with very fast lap times here are going faster, as you might expect, but they're applying a lot of brake. So they're actually applying 75% or 65% of brakes. So they're hitting the brakes hard, even though they're on a straight, not in the corner yet. Whereas the people who have slow laps around here are going slower, but they're not braking yet. And in fact, some of them are even accelerating. So if we move into the corner, we'll see how the behavior changes. So now we're in the corner, we're starting to get into the steepness of the left turn. And what you can see, interestingly, is the speed across all final lap times is quite similar. So what makes a difference? Well, actually, the people who are going fast aren't braking, so that's a little bit counterintuitive. They're not braking as much, even though they're turning a corner. And what you'll see is that people who are slow actually are braking as they come into the corner. Another thing to notice here is the angle of steering. So somebody who's going very fast, they've got a much steeper angle of steering. That means they're turning harder left than the other drivers. And that's a quite good insight to see, learn how to drive that better. So if we go to the final part of the corner, which is possibly the most important, when you come out the corner, you want to go really fast. And what can we see in analytics again? Here you can see that the people who are doing very fast lap times, they're almost full throttle. So that's high acceleration and pedal to the floor. Whereas again, people who are doing slower lap times, they're not got a lot of throttle. And what's interesting here is the steering angle is less, so it's straighter. That means you can point your car straight, which means you can go faster, and the slower laps again can't. So it's quite interesting, just from one analysis, we can learn how to drive without ever getting in a car, just looking at the analytics. It's braking early, turning in tight, and it's getting on the acceleration early, straightening the wheel. But we want to do the data science around this. We want to predict how somebody's doing and what lap time they're going to do. So now we've done analysis and we've got a good understanding of the data, and I've used Spotfire mapping to this. We want to get into feature selection. So feature selection, where we generate features to build the model from, you know, we can't do this on the data that comes out the stream directly because it's too granular. So what we want to use is things like averages. So we've got a rolling 3-second average here, and we've got a cumulative sum. Again, purple points are where people are going fast. So if I highlight this as the fast drivers, and the slow drivers are sort of in a grey colour. And there's a lot of attributes. These are all the attributes that have come out of the game. We've got suspension data, we've got angles of suspension, steering, brake temperatures. There's a lot to go through. We could do this individually, but it's not very scientific, and we might not see all the relationships between it. So what we want to do is actually go back to Team Studio and get it to do the work for us using data science. So what I built was a track feature importance workflow, and it's a pretty simple workflow. So if I just open this and show you it quickly. So what this workflow is going to do is it's going to drag our data, so all our data from the Postgres database, so it's pulling from the same place that Spotfire did. We'll join it all together so we get the data in a nice one big table, and then we're going to generate our features, which is our 3-second averages that we talked about, rolling 3-second averages. But we're going to split the data into the 3 sectors that I mentioned of each track so that the models specialize in those sectors. And then we use an alpine forest, so a random forest, to actually build a quick model, because one of the outputs of this random forest is actually variable importance, and we can see that table here. So we can easily build and learn what's the most important attributes in each sector. But again, we want to use Spotfire's visual power, so we can go into here and look at feature importance. And here you can see per sector. Interestingly, it's not the obvious things like speed, it's ERS, which is energy recovery system, engine temperature, X and Y, so the actual very detailed point on the track. So it's finding the relations that we might not have found as humans just by going through this manually. So now we've got some good idea of features we want to use, and we've got this workflow that we can call. And if I want to change my workflow and do a more in-depth analysis, I can do that all from Spotfire. So I can say use 100 laps, build trees that are 15 depth, and then just hit go, and it instantly reruns that workflow in Team Studio for me and outputs as you saw before. But we want to now use that knowledge and go back to our workspace and build some models to do our predictions. So if I go out to here, I'll show you the workflow we've built for this. So if I just open this workflow, and again, we did this in a collaboration. So I did some of the models, and then my teammate Nora, she actually built a Jupyter-based Keras model as well. So again, it's the same steps, joining all the data, using the same source, building our 3-second averages. But what we've done now is when we get to our sectors, we split into training and test. And we're going to build 3 different models. We've got a linear regression here, a gradient boosted regression. And we've also got this Python notebook, which we can open and again, see how all that works. So write our Python code. So this is using Keras to do a neural network. So we've got a nice spread of different models. And we can then put out our predictions and export that for analysis. So when I run this through for all the training data, so we built a training data set for the event. What we can do is analyze which model predicts the best using a test set. So in Spotfire, again, we've taken out all the details so we can do some really in-depth analysis. And what you can see here is for each sector, you can see the R-squareds of each model. So we've got linear regression here, gradient boosting trees, and our neural network from the Python notebook. And here you can see they all struggle actually in sector 1, as you might expect. There's not a lot of information. It's early on the lap, and we get quite low R-squareds. Sector 2, all the models are about 0.6, 0.65. And then in sector 3, all the models get a lot better, as you'd expect, as we get more information to predict the final lap time. And you get some interesting trends where you can highlight and see what a model struggled with, but other models did well. We can also look at the residuals here as you go out throughout the lap, so the difference between the predicted time and the actual lap time, and see how much spread there is. So a residual average of 0 would mean it's pretty close to perfect. And here we can see the gradient boosted trees has got 1.3, which is a bit better than other models. So we took all this and we assessed it. Now we could mix and match models depending on the sector, but we've decided that gradient boosted trees is our best model overall, as you can see from the R-squareds. So one of the key parts was once we deployed this model, so we had to get this ready and we didn't have a lot of time. I think we actually built this in less than a week. We deployed it and had it running on the first day of the event that I showed you that video from. What we wanted to see then was how good or how much do the models learn. So we took those gradient boosted trees, and this is the same results from the first page where it's built on the data before we started the event. But we retrained the model in real time throughout the event and wanted to understand how much it was learning. So this is the same gradient boosted trees, but rebuilt with the first day after the event. So it's got about an extra 100 laps to learn from. And here you can see the R-squared has improved a little bit for the first sector, quite a bit for the second sector, and then again for the third. And now our average residual is right on 0, so we're getting really close to having a nice spread. But there's some interesting trends here where you see big negatives at the start of the lap in certain models. So one of the key things is we can use R-squareds and we can use simple things like root mean squared errors and other summary statistics. But really, if you want to understand, and we wanted to understand our model in a Formula 1 context, you have to put the data into the domain that you're looking at. So we wanted to look at all the models, but in a Formula 1 way. So what we did was we took some example laps and we plotted the predictions as the lap went through as the person raced their lap. So this is the start of the lap here, end of lap, and this is all the predictions that happened throughout that. And here we've got the model in light blue before the event we trained it on, and then when it gets extra training data. So for instance, you can see the model here that was trained before the event really struggled with this lap, but then after the extra day of training, it was much more close to green line, which is the final lap time. But as I said, you might think that the models aren't very good when they've got big residuals. So for instance, here, the model's predicting almost 10 to 12 seconds less, so a much faster lap time than what actually happened. So it was predicting about 86 seconds when the person did a 96-second lap. If you took just the predictions from the first half of the lap, you'd think this model was really poor, and it would have a really low R-squared with a big residual. But what we can see, and it's really interesting examples, when you put it in the context of driving, something happens here. So the red signifies a mistake by the driver. So here we can see the predictions at this point. And if I zoom in on the map, it shows us the points on the map where that person is. And it's all okay here, but they make a small mistake. So the models start to increase the lap time prediction before the mistake actually happened. So it looks like they touched maybe the grass here, but then there's a really big mistake that happens here. So there's a big spike because the models start to say you're going to drop lots of seconds. So again, if we look at that, here they're coming into this corner, which is quite tricky. And if we highlight this whole section, what you can see actually happened was the person came out here, overshot the corner, was going too fast, then spun, hit a wall, lost the wing, and then got back onto the track. So you can see the model's actually reacting to that. And these X marks are where they've damaged their car. So it does a big spike where it says, oh, you're in the wall, you might be doing a very slow lap now, and then it works out, well, you're back on track, you're going to do this lap time of around 96. But you see, even here, there's another mistake the models react to and predict before it happens, where the person overshoots because they've damaged their car and they've not got any downforce. So if you were assessing this model, you really should only assess it after the final mistake, because the predictions here may well have been very valid, but once the person makes a mistake, you cannot use the history to say whether this model predicted well or not. But here it is predicting very well before, after all the mistakes. So it's just very important to take that and put that into the context. But one of the really interesting things was the model's ability to predict accidents before they happened, which is not something we expected. So one thing we wanted to do was expand upon that a little bit more. And so just very quickly on our last slide, I'll show you what we then did with that. So we've shown that we can predict lap times pretty well. We've shown the models learn. We've learned about how to drive, but we also learned that people are pretty erratic, or people can be very fast and make a single mistake. So here we then decided to expand our crash predictions, where we started to model the likelihood in red of a severe crash, the likelihood in yellow of a minor crash, and actually try and model that through each lap as well. So we're running two predictions, not only predicting their final lap time, but based upon their driving and where they are on the track, how likely are they to damage their car. And that's a work in progress still, but it's been a very interesting piece of work we've done as a team. So at that stage, I will stop and hand over to Helene.
Thank you, Colin. So let's continue with the community update while you and Stephen are looking at the questions to answer. So as always, we give a quick community update at the end of every TIBCO Analytics meetup for those of you that are not familiar with the TIBCO community, and also the latest content for all of you who are active users. So the community is accessible for everyone. You just have to sign up on community.tibco.com. It takes 2 minutes to be able to interact with all the content, which means that you can download it, you can submit questions, that you can download the extensions and the templates that we make available on the exchange. There's a lot of information that we put on the wiki pages to help answer frequently asked questions, lots of tips and tricks. And also, most recently, we've started to publish a lot of blogs, and you're able to submit ideas for the product. So on the blogs, both Stephen and Colin already mentioned this. They have published a detailed description of their demo on the blog, so you can review this and use that as a reference. There are lots of different topics. We talk about the integration with the different cloud providers, about specific capabilities of the products in these blogs, and they're all targeted at technical users like you. What you can also see is that there are 2 COVID-19 related blogs. So this is related to a broader piece of work that the TIBCO data science team is involved in. Michael Connell is leading this. It's really to help support you as a customer and your communities combat the COVID-19 virus. We have shared information in a Spotfire app, and there's a webinar today or later today and also on April 7th to help you interpret that data. It's educational, it's summarizing the COVID-19 outbreak from a data science and visual analytics perspective. So hopefully you'll find it useful. Sticking to that, I guess, TIBCO for Good or Data for Good topic, also wanted to mention that we have published a number of presentations from a TIBCO for Good or a Data Science for Good meetup that we ran in London recently. 4 presentations from the customers and partners that presented there. One of them is on data science or ethics in data science, which is very interesting. And there's also a TIBCO for Good section on the TIBCO website now, which is great because it allows you to sign up to participate in specific TIBCO for Good projects. So please check that out as well. And in terms of the technical I guess capabilities that you've seen displayed today and where Michael started in terms of having a full platform where all the different products work together to build these applications. We now have all of the, I guess, the set of ways that you can use data science with Spotfire complete. You have we were always familiar with TER, but now we can use Spotfire through the data functions with Statistica or Workbench, with Team Studio, and also with open source at Python. So all of these examples are downloadable from the TIBCO Community Exchange and supported with examples on wiki pages. Specifically, we've recently published 3 examples of how to use Spotfire with Statistica or Workbench. We also submitted a new item on the Community Exchange, which is natural language generation. It's a TER function within a Spotfire dashboard that you can download and use. It's a Wikipedia edits data set, so it's easy to understand and then apply it to your own use cases. So that's available now as well. And we continue to expand the anomaly detection assets on the community, also on our TIBCO website. We recently published this solution brief, so I'd encourage you to take a look at that. It's based on our most recent experiences with this topic. And very excitingly, for the last 4 months, or actually the 4th session is coming up on the 15th of April. In addition to the continuing Dr. Spotfire sessions, we now also have Dr. Data Science sessions. These are led by Stephen, who you've just heard. It's every 3rd Wednesday of every month. It's a 30-minute webinar, sort of low barrier entrance for people who want to learn more about data science. It's not product specific, it's just to learn more about a specific topic. It always involves a demo and an explanation of the theory behind what you're seeing. So I'd encourage you to share this with your teams as well as you upskill your teams on data science. We've also reorganized the TIBCO Spotfire YouTube channel quite a bit. So you'll find the videos of this session there, but also we've started recording What's New sessions with our product management teams, YouTube videos you can find there. And then as those of you that are already on the LinkedIn group for Spotfire will have seen, there's a huge amount of new Spotfire enablement videos available as well, and nicely organized for your teams to learn. These are also explained on the community wiki pages itself. As we explained in the previous Geo-Analytics meetup, we have orientation pages and enablement pages for enablement hubs for all of our products. And especially for Spotfire, this is now very complete. There are quick start demos or videos, fundamentals videos, and all of these active user videos, which probably many of you are. So hopefully you'll find this useful to refresh or expand your skills on Spotfire. There's also more interesting meetups. I can't show them all, but I wanted to mention this one for you. 6 steps to develop your inner data science superhero on April 22nd. So I hope you enjoy that. And last but not least, I wanted to introduce you, as some of you may know this already, but there is a TIBCO League, which is for TIBCO customers, which is also complementary to the TIBCO community website and all the other things I've just showed you, but it's a more interactive one-to-one type gamification of all the content that we've shared with you. So it's a way to interact with other TIBCO TIBCO software users, and you get challenges that you can complete. You can earn points. You can share what you're doing with peers who are using similar products, and it's really fun way to interact and to learn the various TIBCO products. So there's a link here, and you can request to join, and we'll look at those and hope that you will all take part. So that was all I wanted to share. I think we have some great questions, so let's go to the Q&A.
Thanks, Elaine. I'll take this on. Good summary. That was great. There's lots going on. Okay, yeah, a few questions came in through the Q&A, and people are welcome to add some more. We may have time. Colin, first one's for you. This person asks, what are the average run times for these models with this big data streaming set?
Yeah, so it's an interesting thing that depends on how far you optimize your models as well. And the model type plays a big part. So for instance, the linear regressions were very rapid to develop. You know, I would say a few minutes to actually pull out a regression model. Whereas the gradient boosted trees, depending on the depth you allowed those trees to go into and the different hyperparameters, they could take, you know, maybe 20, 30 minutes to complete, depending on how much training data you pushed into it, sometimes more. But what you found is we could get it to generate, say, 1,000 different trees, you know, and learn in the way that gradient boosted trees works. But by looking at the way the models were building, it was plateauing in terms of the loss function and how much information it was gaining, i.e. how well it could predict. So you could then rein that back to, say, only build 300 trees and optimize it and bring the speed down. So when we were doing this at events, I think we were getting the build times down to about 20, 30 minutes. So we'd rebuild it every so often. So it's very dependent on the hyperparameters and also the model type you're using.
Great. Yeah, that makes sense. Question just came in actually while I have you here. I'm not sure if you're familiar with this. Is Spotfire used for petroleum reservoir data analysis? I'm a reservoir engineer.
So Spotfire is used extensively in oil and gas and industries and energy industries in general. There's some actually blogs on that in the same blog link that we posted in the chat about some of the work we do there. You know, TIBCO is part of the OSDU as well, you know, subsurface group. So there's a lot of activity around using Spotfire for doing this. Because it's got very good Geo-Analytics capabilities, you can do some quite complex mapping and then pulling all your statistics and data analysis. So there's quite a lot of content on the TIBCO site around customers that we have in that industry, and we have some nice blogs and demos as well.
Great, questions coming in thick and fast. There's one early one that was asked while I was demoing, so I think it's probably related to TIBCO data science, but I'll answer more generally. The question was, what are the data sources supported? So the quite general answer to that for TIBCO's analytics stack is pretty much everything. It's sitting at the bottom of the analytics stack, if you like, is TIBCO data virtualization that can connect to every conceivable data source, as far as I'm concerned. Relational data sources, NoSQL data sources, files, big data sources, Hadoop and Spark and Hive and so on. And bring those into sort of a centralized location and federating queries over those. So we have very broad support for those data sources. For the particular products that you've seen today, also Spotfire itself has connectors. You can find this in the Spotfire documentation. You can just Google it for the particular sources you're looking for. It can connect to, again, a broad variety of both structured relational forms and non-structured. This question was asked while I was demoing, so that's for TIBCO data science. Also itself pretty agnostic in terms of sources, but one kind of interesting thing about the TIBCO data science platform is it pushes computations down into the underlying platform. So certain sources for TIBCO data science are sort of special, right? So relational sources like Oracle and Teradata and Vertica and Postgres and so on. Also cloud-based data sources like Azure SQL Data Warehouse or Redshift. are particularly good for sort of handling large-scale data prep and ETL type operations. When you build those visual workflows that you saw Colin and myself doing, Colin built some on the Postgres database, those will all get pushed down through the underlying SQL. So you get to take advantage of the scalability of the underlying database, and you also handle security better because you're not proliferating data sets. Everything stays where it was. Hadoop is also a sort of special platform for TIBCO data science, Hadoop and Spark and Hive, where you can run full end-to-end machine learning workflows with complex models, even extend those with customized Spark and Python and PySpark models. So broad support for data sources up and down the stack, and for TIBCO data science, specifically relational databases for ETL are well supported, and for machine learning, specifically Hadoop and Spark. Let's go back to the list. Here's another one just came in. What are the OS requirements for running Team Studio? It's a web application that then connects to those underlying data sources. So it's generally the sort of the Linux platforms. You can also run it in the cloud, on Amazon, on Google, on Azure. For actually interacting with it, it's all browser-based, so any platform you like, basically. There are, of course, certifications for certain browsers, but pretty much what you want. Another one that came in fairly recently, maybe Colin, you could handle this one. How Streambase reacts to these generated models? Are they real-time? Can they be real-time?
Yes, that was one of the things that was really impressive. So when you deploy them, so we used our artifact management service to actually deploy them live into Streambase, and the change is instantaneous. So literally when somebody was racing a lap, we deployed a new model and we could see the prediction change as soon as we pushed that into Streambase. So Streambase is using PMML files, and all we're doing is pushing a PMML file, and it instantly updates and uses the new one as you deploy it.
Great, okay. Somebody else asked if we can use other languages besides Python. And yes, you can use Python and R, as well as SQL. And in the data science platform, you can use also HiveQL.
Yeah. And Spotfire, you've also got MATLAB and a few others as well out there.
That's right, great. Elaine, how are we doing? Maybe we should wrap things up now, or maybe time for one or two more?
We've got 3 more minutes, so maybe one more question or two.
Okay. Another one here about AWS and Streambase. So can we connect AWS SageMaker models from Streambase? I am not sure about that. Certainly from within the data science platform, you can connect via our Python Notebooks integration to AWS SageMaker. We've actually got some nice demonstrations of that. I think if you just Google TIBCO Data Science and SageMaker, we have some demos of that Michael and I gave at the AWS reInvent conference. So we have very tight integration with the AWS stack for both building and deploying models using their technologies, not just SageMaker, but also the underlying data sources like EMR and Redshift, also integration with TensorFlow. Any other thoughts on that one, Colin?
Yeah, I mean, I'm not a Streambase expert, but there are a variety of ways Streambase can do the same as Spotfire and data science, and it can call it from Python. It can also use Java, but there might be ways that it's actually integrated into it. But the way I've done it in the past has been using Python. So Streambase can also call services as well. So there might be multiple ways to call it.
Yeah, I think what we did in the reInvent conference, Stephen, we were feeding data through Amazon Kinesis into TIBCO streaming. And then we were pushing data science models from Team Studio into a streaming workflow, and then visualizing anomalies in Spotfire. So we might want to do a version of that for this audience at some point. That was an interesting combination of data science streaming and Spotfire that kind of similar in some ways to what we saw today, but in an AWS environment.
Yeah, that's great. That would be good to show that one off again. And as I mentioned, I think if you just search for our names in AWS reInvent, I think you can find that demonstration online. So take a look at that.
And that was an IoT example. It was in the high-tech manufacturing area.
That's right. That's right. Yeah, good point. Great.
Stephen, I think I'm going to wrap up.
Good.
Okay, so thanks everyone for attending, your participation. We'll look at the questions that have gone unanswered and we'll be in touch. You see our contact details. We'll be sharing the PDF, the videos. You'll be able to see everything on the community that you've learned today. So I hope to see you again in a couple of months. You'll get an invite when we are scheduling the next session, and hope you'll stay safe, and thanks for your participation. Thanks everyone for the presentations today.